Okay, you've heard us use some of these words before, reactants hopefully, and then limiting should be a pretty common word. So we're going to talk about the reactants that limit our reactions. So pages 8 and 9, if you look in your packet, are Cornell notes style, so you get a little bit more freedom, at least at that first part. Most of the rest of it is just going to be working problems. But that first part, write your notes how you feel like it best suits you. Make sure you also have a periodic table and calculator out, because I am going to give you a few calculations to do, so I want you to follow along with mine so you're not completely lost when I leave you on your own. So, what I want to remind you about before I actually get into the chemistry part of this is the problem that we worked before we even started this unit. It was in that cookie stoichiometry activity. Question 5 on the back asked you if you have 6 cups of brown sugar and 3 eggs, and I suppose plenty of other stuff, because there's a lot more stuff in that recipe than just sugar and eggs. It asks us how many batches of cookies could be made. So when we're working this out, what we basically had to do was treat each of these substances, these things, separately. If I have 6 cups of brown sugar, and our recipe says that we need 1 cup of brown sugar per batch, then that means we can do 6 batches. Now, technically, if I wanted to use stoichiometry and dimensional analysis, okay, say if I have 6 cups and there's 1 cup for 1 batch, that's 6 batches worth. Doing the same thing with eggs, if I have 3 eggs and my recipe needs 2 eggs per batch, then I might have to actually pull out, I definitely just tried to write mole instead of batch. So 3 divided by 2 means 1.5 batches. And I saw a lot of you kind of get these numbers out. And then some of you got the right answer and some of you did some pretty crazy things. I saw people adding these together, but we only have enough stuff to make 6 batches of cookies from the sugar and 1.5 batches from the eggs. And so really what the answer here, the true correct answer was 1.5 batches. Because after 1.5 batches, when I run out of eggs, the rest of those cookies aren't going to be worth eating or even making. They're not worth it. So when we do this limiting reactant thing, we're going to have 2 different givens, but it's basically work 2 problems instead of 1, and choose a smaller answer, because that's the only one that we have enough for. We won't be able to finish out the other 4.5 batches because they won't have any eggs. So we're about to reteach you how to do this after you've already done it. So what do we mean by limiting reactant? Let's write down some definitions. The limiting reactant is the reactant that determines the amount of product that is formed, the one that's used up first, and like we just saw, that's the one that always makes a smaller amount, that makes less. The excess is the one we have extra of. It's a reactant that's not completely used up. It's the one that has some left over when the reaction is done. That's the one that makes more. So if I pull this back up again, my limiting reactant was my eggs, because that's what ran out first. And then my excess reactant was my brown sugar, because that's what I was going to have extra of. So, limiting and excess reactants. Now, when we look at this process, how can I tell when it's a limiting reactant problem? Well, I have an example problem that you're going to be working later. If you notice, it says that I have a 16.2 gram piece of aluminum reacting with 61 grams of hydrochloric acid. So it has 2 numbers in that problem, and they're both the information about how much stuff I put into a reaction. And then all it does is ask, how much stuff did I make? And it doesn't tell you which one is which, then you're going to have to use both. You're going to have to do 2 problems because you got 2 givens and it just wants 1 answer. So you work out 2 problems, choose the smaller one. Just to compare, here's a normal problem that we worked earlier in the packet. Notice there's only 1 given in it. So 1 problem to work out, get that 1 answer. We also looked at some percent yield problems, and these do technically have 2 numbers in them, but first off, they're always going to mention percent yield. They're either going to give you your percent yield or ask for it. So that's one sign that you're not doing a limiting reactant problem, because one of these is the amount of stuff that's reacting, and then one of these is the amount of stuff that was formed, that is made. So that's different than my limiting reactants, where both of these are stuff that's reacting together. So, slightly different. Each of these kind of new types of stoichiometry problems has more stuff in it, but percent yield, you just do stoich and then plug into that percent yield equation. Limiting reactants problems, we actually have to do 2 problems. So let's look at a problem. We kept these pretty simple. If you notice, this is a mole to mole problem. So there's not going to be any grams, no masses to mess us up yet. I do need you to change that first time you see the word precipitate to BaSO4, because we want to know how much of this BaSO4 is going to precipitate. So I'm guessing that's going to be a solid, but that doesn't matter for our reaction right now. But I notice I have 2 givens. Which one are we going to use? Why, both, of course. So we're going to set up 2 problems. And I actually went ahead and balanced this reaction for you, with you. We just need those 2 H's and 2 Cl's on the product side. And then I'm going to start with the first number that I see and work this through and answer my question with this first number, then just do it again. So if I start off with that 6 moles of barium chloride, if I have moles of barium chloride on top, then I'm going to use this moles of barium chloride because I'm trying to turn that into this barium sulfate. That's going to be a 1-to-1 ratio. So I'm going to put that 1 mole of BaCl2 on bottom, 1 mole of BaSO4 on top, and I don't even need a calculator to tell this answer is 6. Now, don't worry, I won't forget units on my final answer, but this isn't necessarily my final answer. We have to work out that second problem with that second given first. Now, this time, since I'm starting with H2SO4 and trying to get to my BaSO4, it's a 1-to-1 ratio again. So 1 mole H2SO4 on bottom, BaSO4 on top, and my answer is 5. So now I have to look at these. I have 2 problems from my 2 givens and 2 answers. Which one is my real answer? It's always going to be the smaller one. So I am actually making 5 moles of barium sulfate. That is my answer. Now, what I didn't read before is it asks how many moles of excess reactant remain after completion. So this is saying that I used up all of this. All of this H2SO4 was my limiting reactant, which means I have excess barium chloride. I'm going to have extra, and I want to know how much was extra. So the best way to do that is figure out how much barium chloride I actually had to use to make this much of my product. So I generally start with that answer that I just found as my new given. And what I'm doing here is I'm going to work backwards to figure out how much barium chloride I used to make this much stuff. So once again, if I'm trying to get to barium chloride, and I'm starting from barium sulfate, that's just a 1-to-1 ratio, and that tells me, when these numbers are so simple and straightforward, that I hope that you aren't too confused by the stoich part of things. And this told me I needed 5 moles of barium sulfate in order to make 5 moles of, barium chloride to make the barium sulfate. So if it's asking how much will be left over, how much will remain after completion, I have to take the amount that I actually had that was given to me, that 6 moles, and subtract the amount that was used in order to get the amount that remains. So that's my second answer to their second question. That's really all that we're doing, is 2 givens, 2 problems. And then we might have to do a little third problem and some subtraction at the end if it asks us how much is left over. But I kind of want to put that together into some steps. We already talked about limiting reactant problems. The most basic level, you're going to see 2 givens. So we'll use both givens, work 2 separate stoich problems, and then we're going to choose the smaller answer as my real answer. So that might be all that you do. There are going to be some questions, like that last one, that ask you to find how much of the excess reactant is left over. And just like what we just did, my suggestion is use your answer from that step 2, your real answer for how much you're really making, and work backwards. It's still forwards, it's still stoichiometry, but we're going to work from that product back to the reactants to figure out how much of the excess reactant got used making that product. And then we do a little bit of subtraction and take the given amount that I had minus the part that I used that I just calculated, and that will tell me how much is left over. So it's that second part, the steps 3 and 4, that sometimes people get lost or confused on. And we might ask you that once or maybe twice on the test. I think it's just once. It's a little bit of something, but it is a good skill to know how much to expect to be left over. But as long as we can get this foundation of what do I do when there's two numbers and we don't just shut down, just work two problems. That's really it. That's what we're going to be doing most of the time. So, second problem. Identify the limiting reactant and the moles of excess reactant remaining after the reaction is complete. Okay, so let's balance our equation, of course, first step. And then the first number I see is 3 moles of aluminum. So I'm going to start from that. And it says, it didn't say what product, but I guess we only have one product here. So I'm going from aluminum to aluminum oxide. That's a 4:2 ratio. So I'm going to go ahead and put those 4 moles of aluminum on the bottom, 2 moles of aluminum oxide on top. Once again, the math is pretty straightforward, but that ends up being 1.5. My next given is 3 moles of oxygen. I am making that 3.0. I'm not sure why it just had 1 sig fig there, but let's make it match the other one. And now if I'm going from oxygen to aluminum oxide, that's a 3:2 ratio. So 3 oxygens on the bottom, 2 moles aluminum oxide on top, and that gives me an answer of 2. So which is my actual real answer? Why? 1.5. So that is my answer, 1.5 moles of aluminum oxide. But going back, it says to identify the limiting reactant. And I've just got how much I'm going to make, but remember the limiting reactant is the one that makes less. So my aluminum is the limiting reactant. That means that oxygen was the excess reactant. It's not this answer that's limiting or excess. It's the reactant, the thing we're starting with, that is either limiting or excess. So we identified the limiting reactant. It does want us to figure out how much excess, how many moles excess remain. So we're still going to start from this 1.5 moles, the real answer. That's going to be our new starting place because I know I am making that. And then I just have to go back. Since oxygen was my excess, then I'm going to go from aluminum oxide to oxygen. So put that 2 moles on the bottom, 3 moles on top. This tells me that I had to use 2.3 moles of oxygen to make this product. And if I started with 3, technically, if you're doing the math along with me, that was 2.25, but I rounded that to 2 sig figs to match everything else. That's 2 sig figs. So this is 2.3. And then the 3 that I started with minus the 2.3 that I used means that 0.7 moles would be left over after. So hopefully these problems aren't too scary for you. I'm going to do this one last problem with you and get you started on that last problem that's on the page, but that's going to be the one that you need to finish out. So, first number I see is 9 moles of ammonia. I'm trying to find how much nitrogen monoxide I'm making. So from NH3 to nitrogen monoxide just gives me an answer of 9. Evidently I'm starting with a little bit more oxygen. I've got 10 moles of oxygen there. But when I cancel out that oxygen, turn it into nitrogen monoxide, I end up with a little bit less product. So notice it's not always the number that starts off smaller. I might start off with more stuff, but if the recipe needs more of that stuff, it still might run out first. So at this point I can tell you that oxygen here is our limiting reactant and ammonia is our excess. And the one that makes less, the one that makes more. So our real true answer is 8 moles of nitrogen monoxide. If we want to work backwards, I'm going to start from that 8 moles to my excess, the NH3. So from NO to NH3 says that I had to use 8 moles of nitrogen monoxide to make this stuff. or I guess that was moles of ammonia, to make this nitrogen monoxide. If I started with 9 and I used 8, then I have 1 mole left over. So it is a pretty simple process. Just keep coming back to those steps. Work out your problems, 2 problems, 1 answer. If it does ask you for that moles of excess, then work backwards from your answer and then subtract. So this one is about the same process, but it has mass in it. We want to find mass instead of moles, which is really a little more realistic. We just didn't want the math to be too hard when we're working out 2 problems already anyway. So I'm going to start from my given, the first number I see. This time I already know I'm going to have to do 2 steps because I'm not just going to do mole to mole with our mole ratio up here. I have to convert my iron into iron oxide and then turn those iron oxide moles into grams. So I'm going to do this first half with you, and then I'm going to leave the second part for you to do on your own. So from 4 of these to 2 of those, and so that's moles, but then if I want grams or mass coming out of it, I'm going to put 1 mole on the bottom and add up the mass of Fe2O3 and put that on top. So this is the new setup. It's 1 extra step in that dimensional analysis, that stoichiometry process, but the rest of the process is the same. Multiply across the top, divide across the bottom to find this answer. Do the same again with your second given, this 5 moles of iron. Oh wait, that's what I just did. So use the 6 moles of oxygen to do another problem. Once you get your 2 answers out, decide which one is your real answer. And then it does ask you to work backwards and find the mass of excess reactant remaining after the reaction. Actually, just because I don't want this to be too hard. Every time we see mass or grams, that makes our life harder. And I don't want to make your life hard. So I'm going to say, find the moles of our excess reactant. Now, if you get stuck on that part B, I think I'll stamp you as long as you finished out part A. Found these 2 answers for these first 2 problems and determined which one is your real true answer. So get at least that far. If you need help on that part B stuff, then I'll go over that in class. So good luck. Come in if you need any help with this or have any questions.